Let's look now at the integrals of the other four trig functions. You might remember that we know how to integrate sine x and we know how to integrate cosine x, but we haven't yet learned how to integrate tangent, secant, cotangent, and cosecant. And the reason that we haven't learned it yet is because their integrals involve logarithms. Here are the formulas, and I ask that you write them down and memorize them. The antiderivative of tangent of u is equal to natural log of the absolute value of secant u plus c. The antiderivative of cotangent u is negative natural log of cosecant u plus c. The antiderivative of secant is natural log of the absolute value of secant u plus tangent u plus c. And the antiderivative of cosecant u is negative natural log of cosecant u plus cotangent u plus c. Now there are alternate versions of these, especially the first two, and I'll explain one of those as we go along. So basically you just need to have these memorized so that you can use them when you need them, but I'd like to show you where these formulas come from, both because it's kind of interesting and also because it might help you remember the formulas. So I'm going to derive the first one and the third one for you. And if you're interested, then on your own you can check the second one and the fourth, because they follow similar patterns. So here's a way to figure out the integral of tangent u. And that's to rewrite it as the integral of sine u over cosine u. Basically, because tangent is sine over cosine. Now we're going to do a u substitution. If we set u equal to cosine of u, oops, I can't use the letter u. Tell you what, let's do the original problem with x's rather than u's, so that I can reserve u for my u substitution. Let's find the antiderivative of tangent x. So now if I set u equal to cosine x, then du will be negative sine x dx. And notice I'm pretty close to having what I need. I can move the sine x over with the dx. And all I need is the negative. So let me multiply by a negative 1 and multiply by another negative 1 to cancel it. Then I get negative the integral 1 over u du. All of this becomes du, which is negative natural log of the absolute value of u plus c. So we get negative natural log absolute value of cosine x plus c. Well, if you look at this and the formula I wrote down, those aren't identical. Here's the trick. Using the power rule for logarithms, I can bring this negative 1 in front inside as an exponent, so that I have natural log of the absolute value of cosine of x raised to the negative 1 power plus c. And remember, the reciprocal of cosine is secant. But in some books, you will see negative natural log of cosine written as another formula. So if both of these are correct, we can say that the integral of tangent is natural log of secant, or we can say that it's negative natural log of cosine. I'm pretty exclusively going to use the first one because all the formulas for secants and tangents are linked to one another, and it seems a little bit odd to go outside and use cosines instead. So this is correct. The book's correct when it uses it, and I'll count you correct if you use that formula also. But I will say that I prefer the first one, the one involving secant. Now the formula for integrating secant u involves a really weird trick, but it's such a great trick that it's kind of easy to remember. So let's change the u's to x's once again. And see if we can find an integral formula for secant of x. Now here's the crazy trick. we're going to take that secant x and we're going to multiply it by 1 in a super smart way. We're going to multiply by secant x plus tangent x divided by secant x plus tangent x. Crazy, right? So take that secant and distribute it in the numerator, and you'll get secant squared x plus secant x tangent x over secant x plus tangent x. And now we can make a u substitution. We're going to let u equal the denominator. If u is equal to secant x plus tangent x, then du is equal to the derivative of secant x, which is secant x tangent x, plus the derivative of tangent x, which is secant squared x, dx. Do you see what just happened? Secant x tangent x plus secant squared x. This numerator, along with the dx, is du. So this integral is now the form du over u, which is natural log of the absolute value of u plus c. So that's going to be natural log absolute value secant x plus tangent x plus c. And you see that matches this formula here.